All right, ladies and gentlemen, here I go. I am talking to you guys back. We'll see. Hopefully this thing works. I got my new video camera. I just stuck something through my fingernail. Feels really great. So this is the first video I've done in probably like 7 months because of the internet crash. Then they got rid of everything. So long story short, hopefully this is going to work. Got a new little webcam, and then we'll go from there. Okay, so what we're going to do is I'm going to go through the review sheet for you guys, and we'll kind of walk through everything. So this is number 1, and we have to graph it. So when you're left with something like this, remember we are finding the x of the vertex. We're going to find the x of the vertex, and we're going to do that by labeling this. So we've got A, B, and C. So remember it's negative b over 2a. So negative b would be negative 2 over 2 times 1. 2 times 1. Remember, there's an imaginary 1 right there. So when we get that, we get an answer of my x value equals negative 1. So at that point, my y value will equal negative 1 substituted back in. So we get negative 1 squared plus 2 times negative 1 minus 2. If we clean this up, this is negative 2, that's negative 4. Negative 4 plus 1, because remember this squared is going to give me negative 3. If I get these wrong, sorry about my math. So if we go to graph this, I've got a vertex of negative 1 and negative 3. On these things, if it's off the graph on the answer, the answer is probably wrong. So at that point, I know that it's a parabola, so I've got this shape somewhere that's going to do a U. So then I can use the the quadratic formula, which is going to be negative b plus or minus b squared minus 4ac. I can erase this one. I'll move this one over. All over 2a. And that's going to be my x-intercepts. So if I look at this here, negative b is 2, so negative 2 plus or minus b squared, which is going to be 2 squared minus 4 times 1, and c is the last number, negative 2, all over 2a. 2a is 1. Okay, so let's clean all this up. So we got negative 2 plus or minus 4 plus 8. Negative 4 times negative 2 is 8. 2 squared is 4, so that's 12, square root of 12, all over 2. So this thing just keeps going. So we got negative 2 plus the square root of 12 divided by 2, and we've got negative 2 minus the square root of 12 divided by 2. Those two things. Let's see how it's looking here. Oh, a little too low. Sorry, guys. I will write it over here. So that doesn't go as low as I thought. So let me raise this one up here. There we go. First time's a charm. Not really. Okay, third time is, right? So then we've got negative 2, and I'll put the 2 right there so you guys can barely see it. Okay, so if we clean these up, you can use your calculator. You can use your calculator and get your answers. Sorry, this is going to be, that's going to be negative 2 plus, or we're going to get negative 2 minus the square root of 12 over 2. So we got 2 answers here. Square root of 12 is just over 3, so that's negative 5. So it's about negative 2.5. I'm estimating, you can use your calculator to do this. This one's going to be the square root of 3.5, so that's 1.5. So it's going to be over here somewhere. And so then my graph will look something like that. These are the ones that take you guys the longest right there, okay? All right, so let's tackle the next one. You can hit pause now because I'm going to erase this guy right here. So there's that one. And so then we have y equals 2. X plus 2 squared plus 1. We can erase all this so we can see it. So this is my piece here. Don't forget, we want h and k. H and k. So if I draw my graph, H is going to be the opposite of what's on the inside, which is -2. K is going to be what's on the outside, which is 1. So I am going to go over to -2. Did I write down the right one? Yep, I did. I'm going to go over to -2 and up 1. So I get a graph here. And I got a parabola because it's squared that points up. So I'm not going to get an answer down here. So this is going to just do something like that. That's it on that one, guys. That's number 2 for you. So number 3, let's erase that one. Number 3 asks k squared minus 10k equals -21, and it asks you to solve by factoring. So you can use quadratic formula if you like. I'm not a big quadratic formula guy, except for calculus students. So I got to move this one over. So when I do that, I add 21 to both sides. That gives me 0 there. So now I can factor it. Remember, we got 2 parentheses. What multiplies together to make 21, but adds to make -10? So when I split this up, I can get -7, -3. So -7 times -3 is +21. -7 times -7 plus -3 is -10. So that's my answers. Let's use the zero product property, and I set them equal to 0. And k is equal to 7. K minus 3 equals 0, and k is equal to 3. So those are my 2 answers. Those are my x-intercepts or k-intercepts, whatever you want to call them there. Okay, so let's do the next one. That was number 3, guys. We kind of burned through these bad boys here. So this one here, I'll set it up for you. I'm not going to go all the way through it. 3k squared minus k minus 102. This one's number 4 equals 0. Unless you know how to factor that and get good numbers with 102, I would use this. My x intercepts are equal to -b plus or minus the square root of b squared minus 4ac all over 2a. This is something I would put on your guys' note card that you're going to have on the final. And don't forget to label these. So this will be A right here. This will be B, and don't forget there's an imaginary 1 in front. So B is going to be -1, and then C is -102. So you can take that, plug it in here, and then use your calculator to find it or estimate it, one of the two. If you need help with the calculator, let me know. I will tackle the calculator version stuff for you. So that's how you set up number 4. Number 5. Number 5, I'll get you started on that one also. 14 minus x and equals square root. I'm going to take this thing off. It's in my way. I can look at this one. Minus x equals 2x minus 1. So I need to get rid of the square roots. So I square both sides. I need to find different colored pens next time. I square both sides. So when I square both sides, what happens to the square? The radicals. The radicals disappear. So I get this beautiful little equation that looks like this. All of a sudden I've simplified it all. Yay, us. And then we subtract 2x and subtract 2x, so we get -3x. And then I'm going to subtract 14 and subtract 14 equals -15, because I'm going to add down the column. So if I draw a line right there, -14 minus 14 is 0. That gives me 3x. That gives me 0. This gives me -15. Divide both sides by -3, and x equals 5. So we think we're all good and dandy. Yes, but no, we can't be. We just got to make sure when we plug this back in, we get positive answers. So 14 minus 5 is 9. I'm golden. 2 times 5 is 10 minus 1. So my answer is x minus 5. So when you see a square root, you have to square both sides. All right, guys. This is a semester in a nutshell. Here we go. So 5. This is number 6. 5 to the 2b equals 5 to the -2b. So when this is a while ago, so we've got these exponents. And we had something that was called the 1-to-1 rule. So, meaning if the bases were the same, what could we do? We could cancel them out. So, I get rid of the bases, and my equation becomes another simple equation. So, we're really trying every single time, guys, to make these equations super simple. So now we've got this. We've got, how do I solve for b? Oh, we got trouble here. So what do we got going here? It doesn't really work because if I divide both sides by b, it cancels out. So this is a no solution. This should be a no solution problem because it doesn't work. And I'm looking at it because if I put a negative b in here, that makes that negative. That doesn't work. Yeah, this is a no solution problem. But remember, 1-to-1, that's the main piece of this one. All right, so let's tackle this other bad boy. Let's go on to number 7. Here we go. Number 7. So number 7 looks like this. You have 2 times 7 to the 7a equals 28. So now this one is when I taught you the idea of natural logarithms. So I've got this base. Nothing really looks pleasant right now. So I'm going to divide both sides by 2 and clean this thing up a little bit. So get rid of that. 7 to the 7a equals 14. So now I've got 7 to the 7a. This cannot change into a base of 7. I know it is 2 times 7. That would be great, but that doesn't help us because I need a base of 7. So nothing to an exponent makes 14 because 7 squared is 49. That doesn't give us 14. So what do? Well, we have this beautiful thing called log natural. Okay, I call it log natural because it's the natural log. Okay, and they write it as ln. So if I take the natural log of this side and the natural log of this side, something special happens. This no longer is a power. It actually becomes a coefficient out in front, so we end up with this. We get the natural log of 7 times 7a equals the natural log of 14. And then now I can start simplifying this, and I get 7a equals, divide both sides by the natural log of 7, natural log of 14 divided by the natural log of 7. And then I can plug this into the calculator and get an answer. And then I divide both sides by 7. So I get this. I'm going to write it out long ways for you guys. Divided by the natural log of 7. Divided by 7. If you plug this into a calculator, divide those two first, and then divide by 7, you will get your answer. Don't forget, you can always take the natural log of both sides to get your answer. All right. So here we go. So I'm already on number 8, guys. So number 8 has to do with circles. So if we have circles, so one of the things you might want to put on your note card is the equation of a circle, which is going to be x minus h squared plus y minus k squared equals r squared. And so they tell us a couple of things. Let me. So this is radius. This means radius. And then this is h and k is my center. Whoops, center. So now they want us to create an equation, is what it says. We're using information to write a standard equation. This is standard form. So now they give us our centers. So I got -3/2 and 3/2. This is my center. Okay, so if this is my center is h and k, but in the equation, it's -h and -k. So I've got to change the sign of each of these and put it back into the equation. So I get x plus 3/2 squared, okay, plus k minus 3/2 squared. And they tell us our radius is 1. So 1 squared. That is my equation of the line. Okay, so that's number 8. So number 9, I betcha, is graphing one. Look at that. Touchdown. So we've got x squared. X squared plus y plus 4 squared equals 1. Okay, so we just talked about the equation of a circle. Repeat after me. X minus h squared plus y minus k squared equals r squared. So now let's rewrite this a little differently. X minus 0 squared. That's this guy right there. And then plus y plus 4 squared equals 1. So now I look at this and go, okay, my center is at 0 and down 4. It's negative 4. It's the opposite of what you see. So my h and k is at 0 and negative 4. That's h and k. So I go down to negative 4. My radius squared is equal to 1. That means my radius, if I take the square root of both sides, is 1. So I go out to 1, out to 1, out to 1, out to 1. Draw my bullseye. There's my circle. And you have amazed me with your circle drawing skills. All right. So here we go. All righty here. Oh, 4 more to go. We're rolling, people. And 11 and 12 is brand new. Just for you. My hands aren't even in the screen. I don't even know where I'm at. All right, here we go. So number 10. Number 10. So they ask for the sine of theta. A couple of different things. I would write this in your note card. The sine, So our trig functions are SOHCAHTOA. So remember, this is sine, cosine, tangent. And then I'm not going to write them out up here. This is opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. So you might want to write those down. Now, they want the sine of theta when we have something that looks like this. 15, is it 15? Yeah, 15 and 20. And then theta is right here. Now just remember, theta is just a variable. You could call it x if you wanted to. I don't care. It's just a Greek letter, theta. They have gamma, beta, all those different ones. So now, I need this because sine is opposite over hypotenuse. And I have the number next to this is the adjacent. The number across from theta is the opposite. And the number, the longest side and the side across from the 90 is always the hypotenuse. And I don't know what that is. So we have our handy dandy friend, which is a squared plus b squared equals c squared. Or we can write it this way. Adjacent squared plus opposite squared equals hypotenuse squared. So what's my adjacent, or my A? It's 20 squared. My opposite is 15 squared equals my hypotenuse squared. So we got work to do. 400. 225. 625. So now we've got 625 equals h squared. Now that I'm looking at this, this does not look crooked. When I look at that screen, it's like, sorry about that. So now how do I get h by itself? I have to take the square root of both sides. The square root of 625 is going to be 25. Sorry guys, I got to figure out where I'm at here. Let me draw a line right, where's my hand? Right there. Okay, so that's pretty much as low as I can go right there. I'm going to have to fix that. Next video, okay? I'm not stopping on this one. So 25, so 25 goes here. So my hypotenuse equals 25. My opposite equals 15, so I get 15 over 25. Or if I can divide both of them by 5, I get 3 over 5. And that is my answer for the sine of theta, which leads us into our next two. So here we go. I'm going to leave this one up here, and we're going to number 11. 11. So 11 looks like this. We've got our sides here like that. We got A, we got B, we got C, we got 90 right there. And then I have an X, I have a 2, and I have this weird thing, 24 degrees. That's a 4. Okay, so this right here, it's new to us. But look, they give us this angle. So that means if we talk about what we've been talking about lately, that means the number next to the angle is adjacent. That means the number opposite is opposite. That's why it's the number or the side opposite. So I know my opposite and my adjacent are here. And I have 24. So let's stop right there and let's just look at this logically. What trig function has opposite and adjacent in it? Ding, 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 ding. Tangent has opposite and adjacent. So let's set that up. The tangent of something equals opposite, which is x. We have no clue what that is right now. And we have a 2 underneath. Opposite over adjacent. There we go. What's this something? This something is an angle. What angle do they give us? They give us this angle, which is 24. So now I just got to set it up. And that is on a glare right now. Believe me, there's a 24 right there, guys. It's right there where you cannot see. Okay, so now, how do I get x by itself? Well, we've got a division sign over here, so I'm going to multiply both sides by 2. Cleans this up, and my x is going to equal 2 times the tangent of 24 degrees. So that is going to be my answer. This, you're going to use your calculator for. So you type in tangent 24, hit enter, times it by 2, and that'll give you your answer. So there's that one right there. Okay, so well, here we go, almost done. I'm flying. It's 3:06, or no, it's 3:01. I can't even tell time. Here's where we go, guys. So now it's a brand new one, number 12. Number 12. Dang triangles, they're huge. Triangles, triangles everywhere. And we've got our thing here. We got 14, and we got the tangent of that right there. Okay, so here we go. Here's my theta. It's adjacent. Here's my opposite. It's across. Here's my hypotenuse. It's the long side across from the 90. So I've got those two things. So again, what do I got? I got opposite and I got adjacent. Opposite and adjacent. So So I got tangent. Tangent of what is equal to opposite over adjacent. Now, this is the new thing. So you're almost in the line here. So I'm going to put, we don't know what this angle is. So I'm going to put theta right there. So we need to figure out what theta is. We don't know what that is. So this is the beauty of the calculator. So we have what's called an inverse function. An inverse function of this one, not reciprocal, but inverse function, is the tangent of -1. It is in your calculator. It's right above the tangent. And the tangent of theta, so I'm going to take the inverse tangent of, or it's called the arc tangent, of this side, and then I'm going to do the same thing on this side. So I've got this piece right here. Okay? Now, the tangents on this side cancel, and I'm left with theta. You put in your calculator this exact piece using the inverse tangent button, so you're going to have to hit the second function. You're going to have to hit the second function and then hit tangent, and then put this fraction in there, and I think, don't quote me on this one, it's around 37 degrees in there somewhere. It might be like 36.9 or something like that. So that's how you tackle number 12. Okay, last one. Woo! Did all 13 here, guys. We're rolling through it. Do the same thing for you tomorrow. All right, so we got negative. This is 13, negative 43. Why such big numbers? Who gave you this worksheet? 36. Okay, so there's two things. We're going from degrees to radians, or we're going to go from radians to degrees. Whoops, degrees. Okay, so we're going to go from degrees to radians, or we're going to go from radians to degrees. So this is going to be degrees, so like the little circle sign, right, to pi, or we're going to go from pi to something degrees. See how it's pi first? So this one, we multiply. Let's do it this way. We're going to go from my answer in degrees over pi. This one, I'm going to go with pi over degrees. No, sorry, backwards. Yes, no, correct. I'm confused right now. There we go. Okay, so if this is first in your problem, then you're going to use this. If degrees are given, then you're going to use this one. So if we look at this, if pi is in the problem, I'm going from radians to degrees. So I'm going to take this 43 pi over 36, times it, or multiply it by 180 over pi. So what happens is it cleans things up. Pi's disappeared. And I get this ugly thing, 43 times 180 over 36. 180 divided by 36 is 5, so we're going to get negative 43 times 5, negative 215. Don't quote me on that. Check it in the solutions, but that's my answer. Bada bing, bada boom. 1 through 13 is done. That's how you doing, people. Rock and roll. Hopefully this works out for you.